I'm representing the Advanced Systems Analysis program here at IIASA, and we are working in the area of methods, so we're supposed to develop methods applicable in applied studies that are carried out at IIASA here. And in this context, we'll learn from every experience, because we don't have an idea to use existing methods, just some standard methods to apply to particular problems that we come across here. And therefore we'll learn every time. And I think from my perspective, this little brainstorming that we'll be having here could be a very good learning exercise for the methodologists. And we have several methodologists here in this room, methodologists. And I hope that on the basis of the discussion that we'll be having here, we could come up with some projects. And I'd be really happy to invite all of you to contribute to the design of a future project that could be explored under the umbrella of the Advanced Systems Analysis program. Please do not hesitate to come up with your ideas after the meeting. So let me now come to the point of my kickoff statement. I'd like to start with a somewhat paradoxical statement that all our life is optimization. Indeed, each action, if it is made by a human being, is motivated, right? In other words, if we do something, we optimize something. In other words, so it's a constant process of optimization. The problem is that we never have one goal in front of our eyes. Our goals vary from time to time, and even every time, in every minute, we may have different goals in our minds. The problem of putting priorities onto these goals and choosing between these goals, that's a problem, and that's a real problem. If we follow this line of analysis, we can maybe split the set of all goals into two graph categories: short-term goals and long-term goals. If I have a long-term goal, then I can plan an action to reach that, to optimize my long-term criteria to act today so as to optimize my long-term criteria in the long run. But on the other hand, I may have, and I normally do, some short-term goal in front of my eyes, and I have another action that, in my mind, optimizes that short-term goal. And these actions that optimize long-term and short-term goals are not necessarily in agreement. Moreover, typically, there is this strong gap between the actions that meet the long-term target and the short-term target, right? But there are some exceptions, and that is very remarkable, that in which some exceptional situations in which there is no visible conflict between short-term and long-term actions. And in my mind, systems analysis should pay serious attention to these exceptions, because these exceptions are evidence of a harmony of the world, if you want. The world is really constructed so as it is able to develop sustainably and very, very stably. And multi-optimality is a sort of on the background of stability and sustainable development. And therefore, if we understand some cases in which we have multi-optimality, at least in terms of short-term and long-term objectives, then we may understand how the world is constructed, at least at some pieces, in some situations. So it's perhaps too far-fetched, perhaps, but anyway, it's a sort of, just speculation. In mathematics, multi-optimality is an extremely rare situation. However, even within the framework of mathematical studies, one can come across some situations where the multi-optimality comes in quite naturally. Just let me fix on one example of that sort. It's the so-called, it emerges from the theory of evolutionary games, and it is the so-called, it's famous example, it's the so-called fictitious play dynamics. The fictitious play dynamics model departs from the conjecture that an agent is always trying to pursue his or her very short-term interests and just to respond best to the current situation tomorrow, right? So if we have two players that interact and that forced to interact many times, then in each round, well, that myopic player may pretend to respond best in accordance to his short-term criterion, respond best to the action that has been made by his or her opponent today, in the current round. It's a very myopic, very silly behavior, but it's also best response behavior. Unfortunately, that's very far away from any optimality in the long run. But if the player is a little bit smarter, and if the player takes into account the history of the actions that his or her opponent has undertaken in the past, and takes a sort of average action that he has made in the past, and reacts best to that history, then in some situations, both players, if they follow that strategy, win. Moreover, in the end, they approach the so-called Nash equilibrium point in the game that they play out every round. So in other words, so that myopic, but a little bit clever, slightly clever and smart decision-making pattern, which is myopic, but with a little bit of cleverness, right, leads the players to an entirely and globally optimal situation. And that's one of the examples. Another example, if I have 1 minute. One more minute. Another example comes from the theory of optimal economic growth. So it's a sort of, a trade-off between short-term goal over the development of the firm, for example, and a long-term, and a long-term goal and short-term decisions. And normally short-term decisions are made and without taking account the long-term goal, just according to the practical situation that is currently taking place. But sometimes it is possible to justify that there is not that long distance between short-term and long-term decisions, even in this very complicated process. And there is an instrument that allows us to understand where we can find a resolution to that problem. This is the so-called shadow prices, and a way to estimate shadow prices at every point in time is a key to find a sort of harmony, to arrive at a harmony between short and long-term actions in economic development. I've presented just some thoughts about that in this handout, and if anyone is interested in that, please take it. Thank you.